This is my final project for ECE 570 Artificial Intelligence. My project is an automated image caption generation algorithm, which uses both convolutional neural networks and long short-term memory networks for image caption generation. So let's dive into my README. I'll open this up. The convolutional neural network is used for image feature extraction, and the LSTM is used for generating captions. And the goal is to generate descriptive and contextually relevant captions for images automatically. So there are a couple of prerequisites. The code is all in Python, so you need Python installed. And there are 5 libraries used: TensorFlow, Pandas, NumPy, scikit-learn, and JSON. Here's a command to install all 5. To run the experiments, you just run it using Python 3 final project.py. And the code attribution, all of the code is original. None of it has been taken from external repositories. The architecture is adapted from the architecture presented in the paper Caption Generation of Images using CNN and LSTM by Youssef et al. And the data preprocessing methods are inspired by standard practices in image processing and analysis. So I'll go into the dataset used. We use the Flickr 8K dataset, which can be downloaded from this hyperlink. You'll need to, it's on Kaggle, so you'll need to either sign up or log in with Google to download the dataset, which contains 8,000 images and their captions. So I have this in my directory, so I'll show you. So there will be two things in there's a subfolder called images, which contains all the images, and then captions.txt, which contains the captions for each image. And these captions are used for training and validation. We compare the generated caption from the model to the caption provided from the dataset. There is also a single image dog.jpg, which is used to generate an example caption after training is finished. Couple notes. The model is trained for 5 epochs. This can be adjusted as needed. Training time, the training takes a long time, which I'll show in a bit. The script also uses VGG16, which is a convolutional neural network for feature extraction. Do not write our own convolutional neural network. The weights are pre-trained on ImageNet. The LSTM decoder, however, is a custom TensorFlow model. The number of words in the tokenizer is set to 30, meaning that the caption generated will be 30 words long. Not all images need 30 words to describe them, so this can be changed accordingly. So let's dive into the code. So here are the imports, set parameters. This is all data pre-processing from line 17 on. Split the dataset for training and validation, for both the captions and the images. And here's the encoder, as I just mentioned, VGG16 convolutional neural network. Weights are ImageNet. And then the custom LSTM decoder TensorFlow class. And then image captioning model, which loads both the encoder and decoder, and then has a call function. And then here's training, the training step. And finally, here are 2 functions to pre-process an image and then also generate a caption for an image, which are used to generate a caption for the example file provided dog.jpg. So now I'm going to run the code to illustrate the long training time. Give a second. So 1 out of 5 epochs. And so as you can see, the training per epoch will be around 4 minutes long. So it'll take a total of around 15 to 20 minutes. So you could let this run out. We trained on an external server which used 4 GPUs and a powerful processor. So if you have access to that, I'd highly recommend running this on that to make the training time a lot shorter. And you can always import your own image file and try and generate caption for that. This dog file is just an example. But yeah, so that's my project. Thank you for listening. Here's a picture of the dog again. And yeah,